Okay guys, so what I needed you to do for homework is watch this video and at the end I'll put a problem that I need you to explain to me, okay? So I'm going to explain every problem and it's to your advantage to know how to do all of this since it is review for Algebra 1. Alright, let's go ahead and get started. Alright, number 1 is to simplify the expression. So here we need to follow order of operation. So if you remember, it's please, excuse, my dear Aunt Sally. Okay, or PEMDAS. So we have to do P stands for parentheses first. So inside this parentheses, we're going to subtract. So 2 minus 8. Then we're going to do exponents. So we have a 2 being raised to a 2. So that's going to be 4. And then we can do multiplication. Well, we always want to do either multiplication or division first. These two can be interchangeable, left to right, and so on. So let's go ahead and, let's do 36. From if we go left to right, 36 divided by 4 will be 9, right? And then bring down that times 3, because multiplication will be the next thing. So that's 27. And then the last thing is to bring down the 4 from the front, the 7 from the back, and that will be just addition. Oh, well, sorry, I didn't do 9 times 3 here. So that's 27. I don't know why I just left it at 2. And then I can add them. 4 plus 27 is 31, plus 7 is 38. So that was the correct answer for number 1. Let's go to number 2. Number 2, it says evaluate the expression 4x plus 5y minus 14. Just zoom in a little here so I can write a little bit better, hopefully a little bit more legibly. Okay, so here we're supposed to substitute in place of x, we're going to put a 0, and then in place of y, we're going to do 3/5. Okay, so this is going to go to 0, negative 4 times 0, and then 5. Put a little 1 underneath, so we can multiply 5 times 3 on the top, numerator times numerator, and then 1 times 5, denominator times denominator. And the last thing there is to subtract, but simplify that fraction. That would be 15 divided by 5, which is 3, and then minus 14, negative 11. Number 3. Number 3 asks us to simplify, so we're going to multiply that 4 to the 2, so it's going to be 8x. You can bring down that 1 in the front, nothing's happening to it yet, minus 12, because 4 times negative 3 is negative 12. And then bring down that 1x, and if there's nothing in front, that's a 1. And then we just combine like terms, 8x and 1x, negative 1x, those are like terms, and that'll give me a negative 7x. And then we have 1 minus 12 is negative 11. Alright, number 4. Number 4, you're supposed to just combine like terms. So you have 7x squared minus 5x squared, and that's going to give me 2x squared. So that crosses out these two. And then we're going to do the x's, 4x, and plus 1x is 5x. And then the last thing we have there is the negative 6 plus 7, and that's going to be positive 1. Because they have different signs, so we subtract and keep the sign in the middle. Okay. Again, all of this is review. We've already done it in Algebra 1. But some of us are doing this together and starting from Algebra 2, just writing all this stuff before we just dive in. Alright, number 5. Number 5 is a function. It's pretty much just an equation, but instead of it having a y, it has an f of x. So think of this as a label. And right here where it says find f of negative 1, pretty much what it's saying is go into the equation on this right side, and wherever you see an x, plug in a -1. So that's what we're going to do. Wherever there's an x, we're going to plug in a -1. So I'm just putting in parentheses so I can set it up to substitute in that -1. So -1, -1. So that's going to be -1 squared, or -1 times itself twice will give me a +1. And then -3 times 1 would be -3. And then we move on. 2 times -1 is -2. And bring down that -5. And at the end, you just subtract. -3 minus 2 is -5. Minus another 5, -10. Number 6. On number 6, you're supposed to solve for x. So the first thing to do there is get rid of the 7. So we're going to subtract the 7 on the left of side of the equal sign. But if I do it on the left, I have to do the same thing on the right. So that'll give me -12 on the right side of the equals and bring down what's left, the fraction. Here it says that x is being divided by 3, so we're going to do the opposite. Multiply by 3 on both sides so I can translate the 3 on the left side. -12 times 3 is -36. Okay. Number 7, it says solve the equation for x. We have parentheses, so we want to get rid of that first before we can combine like terms. So we have 5 times x is 5x, 5 times -2, -10. Then we move on to the 4. 4 times 3 is +12, and 4 times x is +4x, so don't forget the plus. Then we bring down the 20 and the equal sign. And then we combine like terms on this left side, the x's with the x's, so that's 9x. And the regular numbers, -10 plus 12 will give me a +2, because opposite signs you subtract and then keep the sign of the larger number. Okay, and then we want to solve for x, so we're going to get rid of the 2 by subtracting a 2. But if I do it to one side, do it to the other, this will let me write. Okay. So that's going to give me 9x equals 18. And then last thing is to divide by 9. Divide by 9, x is 2. Number 8. Number 8, you have an inequality, and it says to which graph would represent this inequality, but you can't do that without actually solving for x. So you need to get rid of that 6. So you're going to subtract the 6 from both sides, and you're going to be left with x is less than or equal to -15. Okay, now that x is by itself, we can graph it, and we would read from the x. It is opening to the 15 or pointing to the x, so it's saying x is less than or equal to -15. So less than or equal to is a closed circle, so this is out and this is out. And then less than, all the numbers that are, well, sorry. Oh, sorry, my bad. I did something wrong. No, 15. Alright, I think, well, the answer is supposed to be -15, so this is the only one that has -15. But I just realized that there's an error, unless I made an error, but no, I don't see it. That it actually should be a closed circle, so, when we were going over this in class, nobody said anything. Alright, well, that's weird. Alright, so our answer, if this was colored in, our answer should be A, because it's less than -15. Okay, let's go on to the next one. Less than or equal to, excuse me. Alright, let's go to number 9. Sorry about the delay there. Okay, it says solve the inequality for x, and we have to get rid of the 5 by subtracting a 5. What I do to one side, do to the other. And then I have negative 3x is less than 15, right? 20 minus 5 is 15. Then the last thing there is to divide by a negative 3, divide by a negative 3, but careful, because when you divide by a negative, it flips the inequality. Okay? So then our answer is B and not D, so careful. All right, number 10. Number 10 says, what is the solution set of the absolute value of 3x minus 2 equals 7? So absolute value makes whatever you have in here positive. So then we're going to solve two equations. The first one is going to be set equal to a positive 7, just like we have there. And the second one is going to be set equal to a negative 7. Because possibly if our answer was a negative 7 inside, it would have had to change to a positive 7 because of the absolute value. So then we add a 2, what I do to one side, I do to the other. So that's 3x equals 9. Then divide by 3, x equals 3. Okay, so this one's out. It's between these. And then the next equation, same thing, add a 2, so that's negative 5, and then bring down the 3x. Last thing, divide by 3, so negative 5. So these are my two answers, negative 5/3, excuse me. So my answer is C. Okay. All this, I'm not going super into detail, well, I kind of am, in solving, but we should already know how to solve, okay, guys? All right, it wants us to, on number 11, which statement is true about the three lines here? And if you can tell that they're parallel. Well, parallel lines have the same slope. But even if you weren't sure this was the answer, for sure they're not crossing at the same x-intercept. They're not, they're all different. They're not crossing at the same y-intercept. They're all different. And they're definitely not the same line, so they're not the same equation. So process of elimination, you could definitely get this answer without having to remember that parallel lines are the same slope. Alright, on number 12, you have to use the point slope formula. y2 minus y1 over x2 minus x1. So our first point is x1 and y1. Our second point is x2 and y2. So that would make negative 7 minus negative 7 on the top. And 1 minus negative 4. Careful the minus and negative. Remember that when you have minus and negative, this together will change to a positive. So that's going to be plus 7 and 1 plus 4 because we have minus of 4. So negative 7 plus 7 is 0, and 1 plus 4 plus 1. Anything divided by 0 divided by anything, excuse me, is 0. Okay, number 13. Number 13 is asking us for slope. So if you remember, slope is rise over run. And it helps us if we pick up 2 points on the graph where it crosses right at a coordinate point. So here's one and here's another. Okay, there it is. And then you count how many did we rise. Okay, and that was 5. And how many did we run? Or it's always how many did we go to the right? Well, that's 2. So then our answer is 5 over 2. So that was. Alright, next one is number 14, which best describes the relationship between the two lines. So it says the lines are parallel. If they were, we would have the same slope, the exact same number, and we don't, so that's not it. The lines are perpendicular. Perpendicular lines have opposite sign slopes and reciprocal. Well, 2 and 1/2 are reciprocals of each other, but they're not opposite sign. They're both positive. 2 and positive 1/2, so it's not perpendicular lines. The lines intersect but are not perpendicular? Possibly. Or D, the lines are the same. Well, they're not. They're not exactly the same line because one has a slope of 2 and one has a slope of 1/2. Right? And one has a y-intercept of 3 and one has a y-intercept of -3. So process of elimination, the answer is C. And if we had a graphing calculator, you could also graph it and see if any of this is true to make you feel a little bit better. Okay, number 15, it says, what is the equation of the line? Obviously, just by looking at it, you read a line from left to right, so our slope is negative. So I'm going to look at my answer choices and see if we can cross out some answers, and we can. Oh no, we can't, sorry. Obviously, my slope is negative. Okay, so we're going to have to pick a point that goes through a coordinate, and the x and y intercept will help us a lot. And you see it's going down 1 and over 1, 2, 3. So it's -1 and over 3 to the right. So our slope is -1/3. So now we can cross out C and D. And then our y-intercept is 1 right here. Like our y-intercept, a +1. So our answer is A. Okay. So again, review on linear equations from Algebra 1 that we should know. Alright, number 6, it says to write this in slope-intercept form. Well, if you could tell, slope-intercept form has all the y's by itself and there's no parentheses. So we need to distribute that 1/3 first inside the parentheses. So 1/3 times x is 1/3 x. 1/3 times -9 is -3. Then on this left side, we can have a 5. So we're going to subtract the 5 so we can get y by itself. So if I subtract the 5 on the left, I subtract the 5 on the right, and my equation is 1/3 x minus 8. Next, number 17. Okay. It says, which equation has a slope of -1/2, -2/7, and contains the point 5, -6. So this is written in point slope form, which is y minus y1 equals m parentheses x minus x1, where this is my x1 and y1. They come from my point, and the slope is our m here. So then it's going to be y, and it's going to be minus a -6, right? Minus y1, sorry, minus a -6 equals 2/7 x minus 5. But careful, minus a negative here is going to change that to y plus 6 equals 2/7 x minus 5. So our answer is, oh, sorry for that. Okay. Number 18. Number 18 is actually easier than it looks. It looks super complicated, but it is to divide this equation by this second equation, or fraction, excuse me. You multiply the first one by what? Well, if you remember your rules of fractions, in order to divide by a fraction, you're going to multiply by its reciprocal. So when it says multiply by what, you just get the reciprocal. So whatever's on the top goes to the bottom, whatever's on the bottom goes to the top. Number 19, some of us might not remember scientific notation, but pretty much it's always written with the decimal on this, right after the first number. So I would actually have to move this to the right, the decimal point originally to the right, 1, 2, 3. So it has to have 3. It has to be raised to the power of 3, 10 to the 3. And then because our number originally was 1, 2, 3 places to the left, it would be a -3. Okay. Next one. Number 20. Number 20 is a review on powers, properties of powers. So we look at the exponents, and when we multiply variables with exponents, we add. Do you remember we add their exponents? So we have z to the t, and then z to the 5 equals 15, z to the 15. We would add the exponents to give us 15. So then t has to be 10. So that when I add 10 plus 5, I would get 15. Okay, number 21. Number 21 is also properties of exponents or properties of powers, where we have an exponent outside the parentheses. In this one, when we have exponents outside, we multiply them by whatever is by the exponents that are inside. So we have c to the 3 and c to the 2, that's going to be c to the 6. Well, 4 has an exponent of 1 and 8 has an exponent of 1. So that is going to be multiplied by the exponent of 2, because that's outside. Or just think of it this way. Everything inside the parentheses has to be raised to a 2, but because the c already has a 3, then we multiply it by 2. So now that takes care of our parentheses, the second set there that had the exponent. But then we still have these variables with exponents in the front. And since there's nothing between them, it's just multiplying. And like in our previous problem, when we multiply variables, we add their exponent. You have a to the 3 and a to the 2, or 3 plus 2 is 5. And then we have b to the 4, but there's no other b to the 4 or any b, so it just stays exactly the same. And then we have c to the 6 and c to the 6, so we add them, and that's going to be c to the 12. Don't forget though, I still have that 4 squared, and that goes in the front. And 4 squared is 4 times itself twice, which is 4 times 4, so it has to be 16. So our answer is A. Number 22, also properties of exponents. Anything raised to the power of 0 is 1. So that's one thing that we would have to remember. So pretty much you can ignore this in the front because 1 times anything is the same thing again. And then we have 3 raised to the negative 2. Remember, if you have a negative exponent, it tells you I don't belong here. I belong on the other side of a fraction. So you have to move that 3 squared to the bottom of a fraction. And now you make the exponent positive. Well, then you simplify 3 squared, or 3 times itself twice, which is 9. 3 squared is 9. So our answer is 1 over 9. Alright, number 23. Almost done. It says, which is the best estimate of the square root of 75? Well, the thing that you can do is think of perfect square numbers and their square roots. So we have 8 times 8 is 64, right? 8 times 8, or 8 squared, is 64. And 9 times 9 is 81. Well, 75 would be right in the middle, right? About. But it would actually be closer to 9. Right? Because this one is about 9. And then 81 minus 75 is 6. So it's actually closer to the 9 squared, or 9 times 9. So that when we would square root 75, it would be closer to 9. So it's B and not C. Alright, number 24. Number 24, it says, what is the simplest radical of the square root of 45? So we would try and find two numbers that multiply to give me 45, but one of them is a perfect square number. And the biggest number would be 9. 9 times 5 gives me 45, and 9 is a perfect square number. So I can square root the 9, but not the 5. So the square root of 9 is 3, but the square root of 5 doesn't have a perfect square root. That's as far as we can go. Let's simplify. So our answer is number 25. It says multiply the binomials. So we're going to do 4 times 3. 4x times 3x is 12x squared. Then 4x times 2 is positive 8x. Then we move on to the negative 5. Negative 5 times 3 is negative 15x. You would let me write. And then negative 4 times 10 is times 2 is negative 10. Then we combine like terms. But there's no other 12x, so, sorry, there's no other x squared, so that's this. Then we have an 8x, a negative 15, those are like terms, and they will combine to give me negative 7x. But nothing else will combine, so bring down the 12x squared and bring down the minus 10. So my answer is negative 7x in the middle. Okay. Alright, next one. 26. It says expand this, so it has 5x minus 6 squared, so pretty much times itself twice. So we're going to do the same thing we did on 25. 5 times 5 is 25, x times x is x squared. 5 times negative 6 is negative 30x, and then 6 times 5 is negative 30x again. And then negative 6 times negative 6 is positive 36. Okay, so just by looking at that positive 36, oops, this one, these two are out. So then we combine like terms, which will always be the middle two terms when you have binomials. Negative 30 and negative 30 will give me negative 60. All right. Number 27, it just wants us to identify the quadratic function. You could have just Googled this one, but it would be negative b plus or minus square root negative 4 all over 2a. So it'd be this one. All right, next. All right, number 28. Pretty much you can use a calculator, but if you're doing this by hand, it says 15% of 9. So 15%, I'm going to change it to a decimal, and I'm going to multiply. I'm going to put 9 in the bottom because it's just one number. So I'm going to multiply, and that's 5, carry a 4. 4 times 9 is 1, plus 4 is 13. And then if I have 2 decimal places, then I put 2 decimal places there. Alright, number 29. It says which equation has the roots of negative 3 and positive 5. So I don't know if you remember this, and I don't expect a lot of people to remember. But when you have factors of a quadratic, if you set each one of them to 0, then they'll give you the roots. So pretty much what would make inside the parentheses go to 0? Well, here a positive 3 and a negative 5, so that's not it. So we're looking to where I would plug in a negative 3 and a positive 5, and the whole thing would go to 0. So it would be this one. Negative 3 plus 3 would be 0, and positive 5 minus 5 would be 0. So that's where the roots are, negative 3 and 5. Alright, let's go to number 30, and that is the last one that you guys have to do in the review, or in the pretest for Algebra 2. And that's the last one I'll go over with you. Oh, number 31, sorry. Alright, so 30 says find the factors. If you're going to do this by hand, then we would do 2 times 10, which is 20. And then we would get the factors of 20. 1 times 20, 2 times 10, 4 times 5, and I think that's it. And we would pick the one that would add, because this is a positive 10 or positive 20, to give me a 9, excuse me. So 4 and 5 will give me 9, but they both have to be negative. So I'm going to put p minus 4 and p minus 5. So when I add them, I'll get a negative 9. But since I multiplied a 2 in, now I'm going to divide a 2 out. Well, this first one will simplify to a 2, but this second one will not simplify, so we're going to do bottoms up. Hopefully you learned it this way. That's how I taught it last year. And that 2 is going to go to the front, and the 5 will just stay where it's at. So my answer is A. Also, you could just work backwards and multiply if you didn't want to factor. Alright, and then the last one, which I don't remember actually going over this in Algebra 1, but I'll show you how to do it. It says simplify the rational expression. You have 2x plus 4 and x minus 4. X squared minus 4. Well, x squared minus 4 can be written as x minus 2 and x plus 2. Why? Because if I would multiply that back in, it would cancel out the middle term and I would end up with a negative 4 at the end. And then I would factor out a 2 in the top, so 2 plus 2, and then these two we would end up having the same number on top as on the bottom, or the same binomial on the top as on the bottom. They will combine, they will cancel out. So it would be left with 2 over x minus 2. But I don't remember doing this with you guys in algebra. Okay.